Welcome to Module 5 of Mathematics course. In this module, we shall be looking at mensuration. Mensuration studies refers to the measurement of lengths, areas, surface areas, and volumes of plane and solid figures. So, this module emphasizes 3D solids such as cubes, cuboids, triangular prisms, cylinders, cones, rectangular base pyramids, examining faces, edges, vertices, and nets to build a spatial visualization. We derive and apply formulae for surface area, curved surface area, and volume for prisms, cylinders, cones, pyramids, and frusтрums, and composite solids while integrating triangle properties and the exterior angle theorem. So in the module, you will find worked examples, proofs, and even exercises to develop computational accuracy and real-world modeling skills. Now let's look at the properties of these common solid shapes. Let's start with cube. A cube have 12 straight edges, 8 vertices, 6 square faces, and so 6 squares joined together, okay, make up a cube. Now a cuboid has 12 straight edges, 8 vertices, 6 rectangular faces. So that is what it means. While a triangular prism has 6 vertices, 9 edges, and 2 triangular end faces, and 3 rectangular lateral faces. Cylinder have 2 circular faces, 1 curved surface, 2 curved edges. While a cone has 1 vertex, 1 circular base, 1 curved surface, and curved edge. Then a rectangular base pyramid, you can see from the photo, have 5 vertices, 8 straight edges, 4 triangular faces, plus 1 rectangular base. Now let's look at their formula. For prism generally, all prism generally, their volume is, you can calculate the volume with this formula. The volume of prisms is equal to area of cross section, or cross sectional area, multiplied by height. So what it means is base area times height. So that is the volume for prism, the general formula for calculating volume of prisms. While for cube, cube volume is equal to L raised to power 3, while surface area is equal to 6L square. So the volume is L raised to power 3. The L represents length. Length times length times length will give you the volume of a cube, while the surface area is 6 times length times length. Then let's look at the cuboid. The cuboid, for the volume of the cuboid, it is length times breadth times height, while surface area of a cuboid is 2 into length times breadth plus length times height plus breadth times height. Know one thing about mathematics, the formula serves as roadmap. So with the formula, you will be able to quickly calculate to arrive at what you are looking for. So let's look at cylinders and cones. The formula for cylinder, the volume of a cylinder, if you have to calculate the volume of a cylinder, the formula is pi r square h, where the pi is equal to 22/7 or 3.143, and r is the radius while h is the height. So but if you are asked to calculate curved surface area, you make use of this formula, 2 pi rh. But if it's total surface area, that means you are combining the two. Total surface area is 2 pi r in bracket h plus r. So or 2 pi r h plus 2 pi r square. So with that, you'll be able to calculate the total surface area of a cylinder. Don't forget, pi is a constant that is numerically equal to 22/7 or 3.143, while r is the radius and h is the height. Now cone, the curved surface area of a cone is equal to pi RL, where L is a slant height. You know a cone have a slant height. You can see from the picture. That's a slant height. Then the total surface area is equal to pi R bracket L plus R. So a sector of radius L forms the cone's curved surface. So arc length of the sector is equal to the circumference. So it equals the circumference, and circumference is 2 pi r. So with all these formulas, so it serves as guidepost for you. If you're asked to find the volume of a cylinder, you know what to apply. If it is the curved surface area of a cone you are asked, you know what to apply. So the formula serves as roadmap to what you want to calculate for. Let's look at this. PQRS is a trapezium cross-section with parallel side 7 cm and 4 cm, and perpendicular height QR equals to 4 cm. So how do you calculate the area? Using the general formula. So to calculate it, half base plus height. You have half plus 7 plus 4. Then multiply by 4. At the end of the day, you have 22 centimeters square. Because the prism length is 12 centimeters. So if you want to calculate the volume, it will be the area times the prism length. So it will be 22 times 12, which will give you 264 centimeter cube. You can also equally calculate for that of cylinder. If diameter is given to you to be 14 centimeter, a cylinder with a diameter of 14 centimeter, you are asked to find the volume, all right, if the height is 4 centimeters. So that diameter that is 14 centimeter, you divide it by 2, because diameter is 2 radius. So to get a radius, you have to divide it by 2. So since diameter is 14 divided by 2 will give you 7 centimeters. So therefore, the radius R is 7 centimeters, while the height already given as 4 centimeters. Don't forget, the volume for a cylinder is pi r square h. So it will be 22 over 7, the pi, times r square is 7 square, which is 49, times the height. So when you calculate together, you have 616 centimeter cube. Like I said, it's very easy, because when you have the formulas, you'll be able to just apply them. What we just did in these examples is to substitute, meaning to replace the already given data in the question. You replace it, in the formula. Let's also talk about calculation on surface area. If you're asked to calculate total surface area TSC of a cylinder, you can calculate it using 2 pi r h plus r. So you can calculate it, right? So you have 2 times 22 over 7 times 7 times 4 plus 7. At the end of the day, you have 484 centimeters square. So note this, always use pi as 22 over 7 unless it is stated otherwise. Sometimes they will ask you to use 3.143. So, but if it is not stated, use pi as 22 over 7. And always state units and show working when computing surface areas and volume. Now let's look at pyramid, cone, frustrums, and composite solids. So the volume of a pyramid is equal to 1 over 3 times base area times height. So if you have a square pyramid, it will be 1 over 3 b square h. While if you have a rectangular pyramid, it will be 1 over 3 length times breadth times height. But for a cone, it will be 1 over 3 pi r square h. But if you are working with a frustrum, a cone or a pyramid, we may be asked to find the volume. So how do you find it? You find it by subtracting smaller similar cone or pyramid from the larger. So curved area uses length and sector relationship for cones. So look at this. If you are given an example, you decompose into the basic solids. For example, cube having edge 28 with square base pyramid height 16 on top. How do you calculate the volume? the volume will be L cube plus 1 over 3 base square times height, which is 28 cube, because the number of edges is 28, which is length 28 cube plus 1 over 3 times 28 square times 16. At the end of the day, you will have 26,133 centimeters square. So you can see all we have just done is to substitute the given data into the formula. Now, geometric reasoning. Let's look at geometric reasoning. If you want to solve geometry, there are some facts you need to know. One is the sum of the angles in a triangle is equal to 180 degrees. So when you are given angles to calculate and the angles are in a triangle, if one of the angles is unknown, you can simply add the other ones you know and remove it from 180 to get your answer. Now, you also take note of a stereo angle theorem. An exterior angle equals the sum of the two opposite interior angles. So you have to also take note of that. Now, what is the application of mensuration? It can be applied in business because area and volume calculations inform warehouse layout. If you see people laying out warehouse, packaging and cargo optimization, the area and volumes calculations are used to lay out warehouse, packaging and cargo optimization. Okay, so in agriculture, it is also important because measurement of land area guides seedling and irrigation planning. So it can be used to measure land area. It also serve as a guidepost for seeding and irrigation planning. Can also be used in control of tank and silo volumes, manage storage and supplies. All right. In sport and science, mensuration ensures regulation field dimensions, pool volumes, and scientific container sizing rely on precise geometry for safety and function. Thank you for listening.